example 4 yesterday, so we are ready for example 5. My goal is to get through maybe 5 through 9 if we can today.
Okay.
And then you'll have homework and you can eat your brownie and do some homework. Okay. So, how do I find critical points?
Derivative.
Okay, so the derivative of this would be what?
1/3 x to the negative 2/3.
Okay, so I could rewrite this, and negative exponent would move it to the bottom. 2/3 means you have the cube root of x squared. Does this ever equal 0?
Yeah.
Yeah.
No.
No, but I do have a critical point because it's undefined where?
0.
At 0. And Bo, we never did find the first page of this notes, I believe. That was one of the missing pieces of paper. Okay. So we tried to help Bo get organized. Bo is missing lots of random pieces of paper, including his homework and the front page of his notes.
Probably because I have actually never seen him open that binder before.
I put his papers in his binder today. I also put things in a file. You now have a folder for scholarship stuff, just so you know.
No.
I haven't done any scholarships.
Alright, so my critical point is at 0. Now I asked you to classify this, as in, is it a max or a min? So we look at our sign line. So something smaller than 0 and something bigger than 0.
-1 and 1.
Alright, so if you put -1 into the original, this is 4 plus the cube root of x. So cube root of -1 is 1. 4 plus 1, 4 plus -1 is, so that is,
How do you know -1 is the answer?
It's
To the cube root.
what to the third power equals -1.
-1.
So that's still positive. I totally plugged that in the wrong spot though, didn't I? I just put that back in the original. I'm supposed to be putting that in my derivative. Oops.
Oh.
But either way, when you put it in here, you're going to square it, so it's a positive. So 1 divided by a positive number is still positive.
They're both positive.
If I put in 1, this is positive, positive is positive. So what does that tell me?
It's still going.
Yeah, this is increasing, and even though I have a critical point, it's still increasing. So it's always increasing, so do we have any maxes or mins?
No.
So I told you, don't just assume that these signs always alternate. They don't. Sometimes we can get the same sign twice. Alright, next thing I want to talk about, the second derivative. Alright, so a second derivative, if we look at a function, we know that the first derivative tells us if this is increasing or decreasing. The second derivative gives us the concavity, or the curvature of our graph. So this graph is what we call concave up. It is curving upwards. Like, think of it as a bowl. Okay, a bowl would hold water. It's concave up. This one is curved downward. Would that hold water if you tried to put water in it?
No.
No.
Straight
It's like it's
Like a
going to
dome.
go straight out. Yep, it's like a dome. So
It's
that
just
one
gonna-
is concave down. Anything's just going to hit it and run off.
First building.
Okay, so when the second derivative is positive, we'll have concave up. When it's negative, we will have concave down. On this graph, I just want to show just to make sure you guys understand. So what's the curvature of the graph right here? That's concave up. What about right here? How is it curved?
Concave down.
Sorry, we said that backwards. This one is concave
Down.
This is concave
Up.
up because it's curving upward. What about right here?
Concave down.
Down.
Up.
Down.
Up.
That's off. Oh, it's still gonna fall out.
Down.
Okay,
Water's still gonna slide
Oh,
out.
the answer's on the bottom.
so I'm not supposed to look at that part. If the second derivative is positive, then the graph is concave up. If the second derivative is negative, it's concave down. So that's what you have room to fill in the blank on that little table, concave up and concave down.
Look at all our new exciting calculus students right there and there.
Listen,
They heard it was Brownie Friday.
Oh, yeah.
That is a
No, it's
question.
because that question
I
came
need
before.
help.
It's that question before.
Not so bad. Alright,
54 is hard. I had to help Jamie yesterday and I did not know what I was doing. I was like,
54?
I'm sorry, you're not doing
54.
this.
I'm
Sorry.
actually on question 1.
I don't remember.
alright, let's look at this one.
What happened next?
So, this figure is showing a honeybee population. Okay? And it wants to know, how does the rate of the population increase over time? Can we agree that this is always increasing?
Yeah.
Yeah. So I want to know, how is it changing over time? When is it the highest? When is it concave up or down? So what would you notice? We know it's always going up. What are the trends? What happens?
We got some concave up and then we got some concave down.
All right, where is it concave up?
From 0 to about 12-ish. 10 maybe.
Looks like, yeah, 12-ish.
We'll say 12 because it's easy.
Okay, and then after 12 it is concave
Down.
down, and it keeps going. We don't have a stopping point. Okay, when was it increasing the fastest? Where specifically on the graph did it rise the fastest?
Like 9 to 12.
Yeah. Okay. At the beginning, was it increasing very quickly? No, it kind of started off with a slow increase and it increased really quickly. What's happening at the end?
It's carrying capacity.
Oh, look at you, hitting our carrying capacity. It's starting to taper off. It's still going up,
Academic
but
weapon.
that is flattening out. Good. So this 12 right here, that's where our graph switched. It was curved upward and then it kind of started curving downward. We know that when our graph switches from increasing to decreasing, that happens at a critical point. Okay? The point where you switch between concave up and concave down is an inflection point. So the inflection point is where the graph of concavity changes. Now, I don't really like the second derivative test, and I don't really use it, but I'm going to go ahead and put it out there. So the second derivative test, if we are looking at a graph, and the first derivative was 0, so that means it was a max or a min, right? And the second derivative is positive. So if it was 0 and then this means a max or min. If the second derivative is positive, that means the graph is curving upward, right? So if it's curving upward, was it a max or was it a min?
Min.
It would have to have been a local min. If the first derivative was 0, so again, that means it was either a max or a min, and the second derivative is negative. Negative means our graph is curving downward, then it is a max. So the second derivative can be used to tell you if it's a max or a min. The problem is, sometimes your critical points are also your inflection points, and then this strategy doesn't really work. So I don't use it too much. I tend to go back to the first derivative to decide maxes or mins, because it wasn't too difficult to make that little sine line and look at it. And that always works versus this working sometimes.
Is it sine line or side line?
Sine, like positive or negative, S-I-G-N.
It's not.
That's I thought it was S-I-N like
I thought you were talking about trig. I was like,
Okay.
Sine
You
as
brought
in a
another
positive
because we have a
sign or a
tangent
negative.
line. I was like, why wouldn't we have a
Sine
sine?
I mean,
line.
logical.
Sine line. Yeah, it is because you tell the signs.
Okay, let's see if we can draw a graph to meet a lot of different environments. So, sketching a possible graph. That means this isn't the only one. We're just trying to find something that works. The first derivative, f prime of x, is greater than 0. What does that tell me?
There is a maximum or minimum.
That's when it
Okay.
equals 0.
Oh.
If the first derivative is positive, what does that tell us? That's increasing. So it's increasing from negative infinity to 1. If the first derivative is negative, that means our graph is
Decreasing.
decreasing. Okay. So at 1, my graph went from increasing to decreasing. So what happened at 1? Critical point. Is it a max or a min?
It's a max.
Okay. So you don't want to get too carried away drawing this yet, but we kind of know roughly we're going to hit a max here, okay? And I'll adjust this graph as needed. That's what we know from the first one. Second requirement. The second derivative. Oh, I'm missing something. Can I write this in?
Yeah.
Second derivative is greater than 0. So the second derivative is positive. That tells me our graph is concave up until we get to -2 and after 2. Second derivative is negative between -2 and 2. Concave down. So 2 and -2 are going to be inflection points where the concavity changes. Typically, we will mark those with little X's on our graph. So I have to alter my picture so far. But I do know that it's curving upward until I get to -2. So curving upward, something like this. And then we have to hit our max. It's curved downward in between those. And then after 2, it's back to curving upward. Okay, so I'm kind of tweaking my graph as I go here, taking in all my new information. The last thing it tells me, at the limit as we go to negative infinity, is -2. Remember horizontal asymptotes? It's telling me as I go forever in the negative direction, this is approaching -2. So this is kind of going down here. As I go forever in the positive direction, it's approaching
0.
So that is our graph. Any questions there?
Go on.
I want to get through 2 more examples, and then that's our stopping point for today. Okay. So girls, I will get to you on your questions in a few more minutes. All right, first half of your homework tonight is going to be finding the concavity. Where is it concave up and concave down? In order to do that, concavity is determined by the second derivative. So we have to do the derivative twice. So my first derivative is
3x greater than 6x.
okay. Then the second derivative would be
6x minus 6.
inflection points are really just the critical points of your second derivative. So where is it 0 or undefined? That's all we're looking for. Is this ever undefined? No. Set it equal to 0 and we get 1. So that is my inflection point.
Inflection point and critical point are the same thing.
Except critical point is for the first derivative and inflection point is the second derivative.
But basically it's
You find them the same way.
got it.
Same concept, just different application.
Yes.
Or just
So
different
then-
concept.
We are going to do the sign line for this second derivative. Okay, so if I plug in a number smaller than 1
0.
and bigger than 1. So if you put in a 0, 6 times 0 minus 6. If you put in a 2, 6 times 2 minus 6. All right. So when my second derivative is negative, my graph is
Concave down.
I'm just going to abbreviate that with CD. So that's from negative infinity to 1. And it is concave up from
1 to
1 to infinity.
We're really not doing anything different from what we've already done.
Nope, it's just the second derivative.
It is called something different.
But all the
Mathematics.
same mathematics. Okay, last thing I'm going to do. Next week we're going to be drawing graphs and putting all the stuff that we've been working on a graph. I am going to give you a couple like this tonight, only 2. Your homework is a whole 7 questions. So we are going to do one of them where we use all this information and draw a graph, and this is where I end today. So we'll do this example, and then you have time to work. So I want to take this curve, and we are going to find everything. All right. I want to know critical points, maxes and mins, increasing, decreasing, concavity, all of that. So what do we do first?
First derivative.
First derivative. So what's my derivative?
For x cubed minus 12x squared.
And how do we find the critical points from here?
Is that equal to 0?
What could I pull out of that?
4x squared.
So that leaves me with x minus 3 equals 0. So what are my critical points?
X equals 3.
And 0.
X equals 0 and 3 are my critical points. And once we know critical points, we can decide increasing and decreasing in max and min. We do our sign line. So smaller than 0.
Negative 1.
In between.
1.
Bigger.
4.
If you put in negative 1, negative 1 squared is positive, negative 1 minus 3 is negative. So that section is
Positive.
negative, right? Positive times a negative.
Oh, I thought negative 1 minus 3 was negative.
It is.
Wait, where's the positive again?
The
Oh,
negative
I
1
thought that
squared.
part was positive. Just kidding.
And then when you take a positive times a negative.
It's
you get
negative. Yep.
Okay, if I put in a 1, 4 times 1 squared is positive. 1 minus 3 is negative. So it becomes negative. Alright, if I put in a 4, 4 squared is positive, 4 minus 3 is positive, so that section is positive. So, I know my graph is decreasing where?
Negative infinity to 3.
Why don't we have to break it up and say negative infinity to 0 and 0 to 3?
Because it's decreasing
It's
the
the
whole
same
time.
thing, yeah. Where is it increasing? 3 to infinity. So, maxes or mins, what do we have? At 3, we were decreasing and we switched to increasing, so that means the local min. Okay, and how do we get the y value? So if we put a 3 into the original, 3 to the 4th is 81, minus 4 times 27, so we should get negative 27. Do we have a max?
No.
Alright. So we have already done critical points, increasing, decreasing, max and min. We learned how to do all of that yesterday. Today's piece is the inflection points and concavity. So we need the second derivative. So what's our second derivative?
12x squared minus 24x.
And inflection points are where the second derivative is 0 or undefined. So if I set that equal to 0, we could take out a 12x, x minus 2. So what are my inflection points?
2 and 0.
So now let's check our concavity. So all of this information is for the second derivative. So we're doing a sign line for the second derivative. So we need our test points. So if we put in negative 1, 12 times negative 1 is negative, negative 1 minus 2 is negative, negative times negative.
Positive.
If we put in a 1, 12 times 1 is positive, 1 minus 2 is negative, positive times negative. Put in a 3, 12 times 3 is positive, 3 minus 2 is positive, so that is positive. So what does this tell me? All I'm wanting is concave up and concave down. So it's concave up from,
Wait, I have to draw this. It's hard for me.
and concave down where it was negative 0 to 2. Alright, so that's all my information. Let's graph it. Alright, so I have a min at negative, or at 3, negative 27. I'm just gonna count by tens on my y. Inflection points, I like to plot these with an X. So let's get the actual points so we can place them on our graph. If you put 0 into the original, what do we get out?
0.
So 0, 0 is an inflection point. So I'm just going to put a little X there. When I put 2 into the original, we get 16 minus 32, so negative 16. So 2, negative 16 is an X. All right. So now we graph this. Look at our information. My graph needs to be decreasing until I get to this 3. Okay, so it's falling this whole time. Now I know it starts out concave up. That means my two options when I draw this, it could be decreasing like this, or it could be decreasing like this. If it's concave up, which of those do I want?
Second.
The second option. Okay, so it's decreasing, curved upward. What happens between 0 and 2? It curves downward. So it's a subtle change, but you guys see how my curvature kind of changed right there? Oops. Trying to make it better and made it worse there. And then it goes back to being curved upward forever. So we're curved upward. When we hit 3, 3 is my min, and my graph starts increasing. So we just graph that column 1. It is tricky. We will be practicing a lot more of those next week. So I've really taught all the content from this section, but we will spend all next week on the same thing, just looking at it. So I have a handout.